So today we're going to talk about simplifying products and quotients involving radicals. So this is a problem that says the square root of 3 times the quantity of the square root of 6 plus 7. You probably recognize that this is a problem that can be simplified using the distributive property. And so we are going to do just that. So just like we would if these were any kind of numbers, we're going to multiply the first term times the first term of the group, and then this term times the second term in the group. So it's the square root of 3 times the square root of 6 is the square root of 18. And the square root of 3 times 7 is, we're just going to reverse that to say 7 times the square root of 3. So just purely distributive property. But now we need to look at any other opportunities to simplify. And you probably recognize that the square root of 18 could be simplified to thinking about the square root of 9 times the square root of 2. And the square root of 9 is 3. And we still have the square root of 2 plus 7 times the square root of 3. This would be the product that you get when you multiply these two expressions. So let's try another one. So this is the square root of 5 times quantity of 2 plus the square root of 10. So same thing, multiply the first square root of 5 times the first part of the group, and then the square root of 5 times the square root of 10. So 2 times the square root of 5 plus the square root of 50. The square root of 50 does have a perfect square factor of 25. And so now we have, we still have 2 times the square root of 5, but now we can simplify this second part into 5 times the square root of 2. And we can't combine those because they're not like terms, so we'll just stop there. So now we can include variables and follow the same process. Square root of 2x times the quantity of the square root of 6x minus 11. Multiply, multiply, and then simplify. So this would be the square root of 12x squared minus 11 times the square root of 2x. 12x squared, definitely we can find the square root of x squared, which is x. And 12 we could think about as 4 times 3. Square root of 4 is 2. We're left with the square root of 3. And then this is already in its simplest form. That is our simplified product of multiplying those two quantities. So here's an example of a problem involving multiplication of two binomials. Now the process for multiplying binomials is the same regardless of what kind of numbers or variables they are. So just because these have radicals doesn't make it any different. So we start by thinking about the first term here times the first term here. Square root of 5 times the square root of 5 would be the square root of 25, or 5. Then we would take that same first term here, multiplied by the second term here. The square root of 5 times the square root of 15 would be the square root of 75. So then we go to the second term in the first group, negative 2 square roots of 15, and we multiply that times the square root of 5. So in this case, the whole numbers remains on the outside and the two radicals get multiplied. And then we do the same negative 2 square roots of 15 times the square root of 15 here. And so square root of 15 times the square root of 15 would be the square root of 225, which is 15, times the negative 2 would be negative 30. Now, we have some like terms here. Square roots of 75 can be combined. So you have a positive square root of 75 minus 2 square roots of 75 would give you a negative square root of 75. And then we can combine the 5 and the negative 30 to give you negative 25 minus the square root of 75. Now, square root of 75 can be simplified. It has a perfect square factor of 25. So we could take the square root of 25 out of that. So first we have this square root, or this negative 25, and then we would subtract out the square root of 25, which is 5, and we're left with the square root of 3. So this is the product of these two binomials. Let's think back on when we were multiplying binomials. There was a pattern that we saw when we squared a binomial, and that's what this is. But let's go ahead and write it out and then see if you remember what that pattern was. So it would be the square root of 7 plus 4 times the square root of 7 plus 4. So again, applying FOIL, or first outside, inside, last, you would multiply square root of 7 times the square root of 7, which would be the square root of 49, which is 7. Square root of 7 times 4 would be 4 times the square root of 7. We're doing that again. It's part of that pattern. And then 4 times 4 is 16. So we can combine our whole numbers, our constants, to get 23. And then we can combine our 4 square roots of 7 to get 8 square roots of 7. So what was the pattern? Well, the pattern was that we squared this term, we squared the first term to get 7, we squared the second term to get 16, and then we multiplied the two terms and doubled it. So 4 square roots of 7 doubled would give you the 8. So now, rather than squaring the binomial, we're looking at the difference of squares. And again, if you remember, difference of squares is we have the same first term, and then we have opposite second terms. So what's the pattern here? Well, let's multiply it out and see if we remember. Square root of 7 times the square root of 7 would be 7. Square root of 7 times negative 4 times the square root of 7. Positive 4 times the square root of 7. And then 4 times negative 4, negative 16. So the thing about difference of squares is that you get this 0 pair here. And so you're left with 7 minus 16, or negative 9. So here, when we find the difference of squares involving radicals, we end up with a whole number, not even a radical. So the pattern, you square the first term and you square the second time, but it's going to be negative, right? And then this combination, you get one positive, one negative, so it becomes a 0 pair. So what we just did, that finding the difference of squares has another name in terms of what this represents. When you have two terms that are the same first term with opposite second terms, we call this conjugates. So conjugates is what happens when you use difference of squares. This is going to be important as we move forward. So let's just quickly do the multiplication on this one. So we could recognize its difference of squares. So we could square the first term, and we could do the negative square of the second term, and we get 3. Because we ignored that middle multiplication because we know it creates a 0 pair. So quick and easy, right? So now, how do we use this? This is going to be used to help us simplify quotients. That means we have division problems. Division problems, if you remember before, we talked about not wanting to have any radicals in the denominator. So we need to rationalize the denominator in such a way that we get rid of the radicals. And we can do this using difference of squares. So if we multiply this by a form of 1 in which we can get rid of the radicals, then we will have accomplished that. So we use the conjugate of this denominator, which would be the same first term and the opposite second term. And we want to make this a form of 1. So what happens then is we know that we square the first term, which is 5, and we do the opposite of the square of the second term, which is minus 2, and we get 3. So the denominator is going to be 3 with this multiplying by this form of 1. So now, before I multiply the numerator, I just want to show you what we have. we have 6 times the square root of 5 plus the square root of 2. And if you're noticing, if you're really paying attention, you're going to see that there's an opportunity to simplify here by a factor of 3. So what's left is 2 times the quantity of the square root of 5 plus the square root of 2. And we could go ahead and do that multiplication now. And that is the division answer we are looking for. All right, let's try one more together. Keeping in mind that we want to get rid of the radicals, that means we can multiply by its conjugate, which is creating a difference of square problems. So square root of 5 minus the square root of 5 is the conjugate to the square root of 7 plus the square root of 5. So square the first term, you get 7. Square the second term is 5, and we're going to do the opposite. So really we have a 2 in the denominator. So what's in the numerator? We have 4 times the square root of 7 minus the square root of 5. And again, we have an opportunity to simplify it here first. And I would do that. So now we have 2 times the square root of 7 minus 2 times the square root of 5 after you multiply that. Okay? All right, give it a try on your own. Let's see how you do.